watch us build this thing and complain about the way we did it, or you can get on board and help steer this ship. So he called my bluff. I was too excited to not join this movement, and I jumped in headfirst with this idea that we could use genetic engineering to help fight the biodiversity crisis. As Ben was talking about woolly mammoths, I was thinking about the species you see above me here. I was thinking, how can we use these technologies to help change the narrative for species like the northern white rhino? How could we use genetic engineering to help solve inbreeding depression in the Mauritian pink pigeon population? Those became really powerful, exciting tools for me as a conservationist, for me as a person, and for me as a very mission-oriented individual to say, we can really change the narrative here. I don't care if you are really excited about woolly mammoths, but I do care if you're really excited about the power of biotechnology as a conservation tool. And I think that's where we're heading. And we'll talk about woolly mammoths, don't worry, that's in here. So with this biodiversity crisis in mind, Colossal launched in 2021. So we're only a little more than 3 years old at this point. I will say we've been able to get a lot of attention, as you might imagine. We launched with crazy headlines about woolly mammoths, and then Tasmanian tigers, and now dodos. That's helped us create this amazing investor base that's helped launch a company in just 3 years' time. Biotechnology is not a cheap hobby. It requires a lot of investor fundraising. We are a for-profit endeavor on the Colossal Biosciences side, where we are creating novel technologies that can be monetized. However, everything we create for conservation is absolutely free to the conservation world and to the natural world. So we launched with this idea that we could make extinction a thing of the past. Now, as I mentioned before, to me, this is really a two-fronted war. The first is de-extinction, reversing extinction. In order to make an extinction a thing of the past, you have to be able to undo extinctions that have or will occur. And that's what we're doing. Now, if you're anything like me, the first thought you had was, we've seen this movie, we've been here, right? I get it. I'm right there with you. I will say some basic facts. It's impossible to bring back dinosaurs. There is no living DNA. If there were, my boss probably would have tried. But our chief scientist, Beth Shapiro, she's a world-leading expert in ancient DNA. She's actually tried to extract DNA from amber. Turns out all you get is mostly just crud from the amber, and amber is a really bad preservative. So we know dinosaurs aren't coming, right? However, with this idea of de-extinction and the power of what it could mean, you have to ask yourselves, well, can you literally create a replica of the species that we lost, right? The answer is no, right? We can't do that. That's not how de-extinction works. I'll get into it. We'll zoom in to one example of de-extinction where I can show you how de-extinction occurs. But the way that we think about de-extinction is with this idea of de-extincting core genes, core phenotypes within specific species that allow us to have an animal return to a landscape to perform specific ecosystem functions. As we know, as we lose species through the ecosystem, the functions degrade, the ecosystem as a whole degrades. If we can begin figuring out how to restore those functions, we can restore natural processes that help promote a myriad of things, whether that's biodiversity lift or carbon sequestration, or in some cases, maybe just grabbing the attention of the world about look what's happening, look what's possible. There is more hope than there is fear for the natural world. So with this in mind, Colossal, like I said, launched initially with the idea that we could restore a woolly mammoth to the northern reaches of Alaska, all the way into the Arctic Circle. Try to restore that biodiverse Mammoth Steppe ecosystem that existed there one day. You know. That also promotes additional biodiversity in a region that's pretty lacking biodiversity, as well as gives us an opportunity to help improve carbon sequestration in an area with very large carbon sinks. That got a lot of attention. That got us off and rolling, and quickly our phones started ringing from researchers around the world saying, well, the woolly mammoth's cool and all, but have you thought about Tasmanian tiger? What can we do for Tasmania and the thylacine? And so we teamed up with the University of Melbourne pretty quickly. Dr. Andrew Pask leads a lab at University of Melbourne, aptly named Tiger, with this idea of restoring the Tasmanian tiger. So we joined forces, and now we are looking to bring back the Tasmanian tiger for the first time in 89 years. And finally, we just most recently announced our endeavor to restore the dodo, sort of an icon of extinction, an icon of man-driven extinction. In just about 80 years' time from the moment the dodo was discovered, it was extinct. It is a real icon of what negative pressures humanity can have on nature. So these are the three projects. I'll zoom into one later. But the real question here is, so you have target species, how the hell are you going to make the thing, right? Well, that's the right question. So it's really this intersection of all these emerging technologies that have been coming out and are already at a point of where the state of the possible is here today. What we're doing is merging these into one intersection, into one company, where we can focus on how to restore ecosystem functions through species restoration. In order to do that, we have to have these amazing technological cores within our company. Our company is much larger, I think, than most people expect. We have about 150 full-time staff. About 100 of those are PhD researchers that dedicate their lives in the laboratory to things like genetic engineering, genome sequencing, biobanking, reproductive science, right? In order to restore anything from the past, we first have to understand what it was. So we have a huge core that's focused on genome sequencing. How can you sequence the animals that exist today so we can literally create cloud copies of that species? But also, how can you reach back in time and use ancient DNA sampling techniques in order to sequence what was? And that's where we come up with woolly mammoth DNA. That's where we get Tasmanian tiger genomes. We also have a huge focus on biobanking. All of this takes extreme cell work, and cell biology is really difficult. Luckily, I don't have to do it because we'd be screwed. But the work that they're doing is advancing cell culture for endangered species. And that's what's really incredible to me. And then finally, we need to focus on things like disease mitigation. If we're going to create a species that hasn't existed in 4,000 years, what diseases would it be prone to? What diseases could it introduce? How could it be more resistant to an ever-changing climate of tomorrow, not what it existed in yesterday? So with all these questions and these technologies in mind, this year we were really excited to announce this idea that we are launching the Colossal Foundation. So about 5 months ago, we went public with this idea that a nonprofit foundation should be spun out of Colossal and house all of the conservation projects. So where the rubber meets the road, where the technology meets need in nature, the Colossal Foundation was built to focus on just that thing. So we built what we call the Colossal Species Model, which is this idea that we use de-extinction as a flagship project. Think of it as a large tanker going through the middle of the ocean. In the wake of that massive tanker, it can pull tons and tons of projects along with it. It brings attention, it brings funding, it brings technological development. So those technologies that I introduced just 2 slides ago, we sort of built into this stack and create a workflow. From the de-extinction project, the advancement of each and every one of these technologies ends up trickling into our endangered species programs. So when we launched the Woolly Mammoth Project, we thought, cool, you know what we should do? We should open up the Googles. We should figure out what does an Asian elephant genome look like. Well, it turned out that didn't exist. There was no reference level quality genome that existed for Asian elephants. One of the most charismatic, probably most overfunded relative to other species of needs species out there. And we didn't even have simple things like understanding what their entire genome looked like. So we started investing there. Then we understood, well, there's also this horrible virus, the EHV, which is a herpes virus that causes hemorrhagic disease, mostly in what we thought was captive Asian elephants. Turns out it's in both elephants and also in nature now. How can we help with that? Well, we know that we can do all the sequencing, we can help devise vaccine plans, and we can partner with some of the world's leading experts like Dr. Paul Ling to create a vaccine for elephants to protect them against EHV. And in just 18 months, we did just that. We just launched that vaccine 3 months ago, so very exciting news. But as you might imagine, none of this can really be done by one organization. Can't really be done in one country. I mean, we're talking about global scales of rewilding using species that have been lost to the natural world. So in order to do that, we've been really busy trying to create global collaborations. We've been working on the nonprofit side quite a bit to build nonprofit partnerships to see how we can apply our technologies to species and programs that they actively already have that we can use our technology, our funding, our storytelling as a way to accelerate and drive progress for each of those organizations. Additionally, as an American company that sits in the backyard of Native American tribal lands, it became very apparent to us and very important to us that we need to act as conservationists through the lens of our indigenous peoples. And so last year we also announced the launch of the Colossal Indigenous Council, which is a council of North American tribal conservation leaders that help us devise strategies for conservation, allows us a mechanism in which to apply our technologies to their conservation, and then also, hopefully, acts as a model for how we can coexist with nature. Because, no offense to Europeans here, as Europeans moved into North America, we sort of destroyed what was a really neat balance that Native Americans had with nature. So that's my long-winded explanation of who I am, what I do, and what we're doing. But I thought it'd be helpful maybe if we take a zoom in to one of our projects here. So we talked about this just a couple chats ago, but this is the Tasmanian tiger, or the thylacine. Went extinct in 1936. This image comes from the Hobart Zoo. It's one of the last images ever taken of a live Tasmanian tiger. The species was driven to extinction by government-sponsored eradication programs for fear of sheep farming, right? As we know now, we know better. They probably really weren't much of a threat to sheep. But unfortunately, in the short time that eradication program was in place, it did its job, and we lost the Tasmanian tiger. So our focus on Tasmanian tiger restoration is this idea of restoring the Tasmanian tiger so we can help rewild sections of Tasmania. Similar to what we've seen with successes, and I fear to bring up the wolf with Luigi here, but successes of apex predator restoration. We believe that the unfortunate reality for Tasmania, for Australia, is that it has become a hallmark example of mammalian extinction, of invasive species, and of wildlife disease. Our belief is that the restoration of a predator like the Tasmanian tiger to Tasmania could help curb invasive species, could help slow the spread of things like facial tumor disease in Tasmanian devils. So we're focusing on building strategies right now with partners in Tasmania with this idea that one day this moonshot project will come through and it will lead to the ability for us to restore Tasmanian tigers to your landscape. In order to do that, there's a lot of work we need to do today, right? And that's the idea. This flagship, or this moonshot, acts as this beacon of hope so that we can inspire work today. Real quickly, because most people will ask this, is how the hell do you make a Tasmanian tiger? Well, that's the right question. So just quickly, we'll go through all the science, because I'm the expert in this, which I promise you I'm not. But as I mentioned, we really start on the front end with the ancient DNA problem. Can you find samples, tissues, anything remaining of this lost species? In the case of the Tasmanian tiger, we're extremely lucky. Some museum curator thoughtfully put 3 pups from a female that was killed into a jar of ethanol and preserved these beautiful specimens for us to sequence. We have since created the first ever telomere to telomere genome for an extinct species. So that's published and that's out there today. At the same time, you need to identify who is the closest living relative to your Tasmanian tiger or your thylacine. Well, these are dasyurids. They don't look like most of the other dasyurids that you might think of, things like quoll or things like Tasmanian devils. But the closest, they're sort of equally divergent from all dasyurids. The most accessible dasyurid out there is a fat-tailed dunner. And if you're not familiar with fat-tailed dunnards, it's that little mouse-looking thing right here. Looks a lot like a Tasmanian tiger, as you might imagine. Significant engineering challenges, but it's much more accessible. And it was already being used as a research model species in Australia, so it had its advantages. So we create that reference genome. We've also created a telomere to telomere genome for the dunnart. And then we plug in all that data, and this is how I believe it works. We go presto changeo on this amazing AI-powered computational biology software platform, and it literally compares and contrasts the genome to tell us exactly where the Tasmanian tiger and the fat-tailed dunnart are the same. And more importantly, exactly where they are always different. that always different idea tells us this is specific to being a thylacine. Once we have those edits in mind, we can use the amazing technology that's been developed over the last 20 years in genome engineering to use things like CRISPR-Cas9 systems, prime editing, base editing, in order to begin to make changes to the genome of the cells in a fat-tailed dunnart. And over time, after about 100,000 edits, you get to the point where you've achieved a cell line of an extinct species, of a Tasmanian tiger. Once that cell line is produced, we use reproductive science and surrogacy to implant a Tasmanian tiger embryo into a small fat-tailed dunnart. And just 13 and a half short days later, it gives birth to the first ever Tasmanian tiger to be born since 1936. As you might imagine, that small mouse can't carry that animal very long. Luckily, its gestation is 13 and a half days. So we also have this amazing hardware engineering team that's creating artificial pouches. So one of our things is create what we call the exo pouch, which is a synthetic pouch, even comes with real live pouch jam, and artificial teats, artificial milk. So you imagine all the engineering challenges, all the investment that go into this, and this becomes a very powerful tool for our partners, say at Bonarang Wildlife in Tasmania, that are trying to rehabilitate pinkies from roadkill moms. So this is where we start to find all those opportunities to begin to apply our technology to endangered species. Finally, you get an adult thylacine, and then that's when I come to you guys and I go, how the hell do you rewild something, right? That's what we're doing now. We're trying to lay the groundwork today with partners in Tasmania to begin to create ecosystems that could receive a thylacine one day. But along that journey, you also find some really neat tricks. So as we learn to begin to engineer dasyurids, we can identify, in the Northern Territory, mainland Australia, the northern quoll is critically endangered. And it's endangered predominantly because of the invasive cane toad. The cane toad is really tasty. It's hard to pass up on. And the quolls go and eat them, and they succumb to the bufotoxin. Well, as it turns out, a given time, quolls probably could figure out how to adapt to that toxin. But with all the pressures we put on nature, we don't give them the room to be able to adapt over those 1,000 years, over those hundreds of generations. So we'd probably lose the quoll without intervention. So what we did is we looked at species that co-evolved with the cane toad from South America. And as it turns out, they have a natural genetic resistance to the bufotoxin. And even better, as it turns out, that protein is only a 1 base pair change in the entire animal's genome. So we partnered again with our friends at the University of Melbourne, and we're working right now creating cane toad toxin resistant quolls. So that's really exciting. We just announced that project about a year ago, and I would say we're probably about another year before we should have some exciting developments to announce. Now, where things get really weird is when you start talking about genetic engineering and you get in a room with a bunch of nerds that want to talk about genetic engineering, wild ideas come up. And even though this isn't directly related to Tasmanian tigers or to marsupials in general, one thing Australia is facing is this really disproportionate impact from the chytrid virus on their endangered amphibian populations. And when we start having beers with Australians in a room talking about all the things we want to solve, one of the projects that came up was this idea that what could we do for the chytrid virus? Well, as it turns out, we brainstormed this really neat idea that there was a researcher at University of Melbourne that helped us devise this idea that the alpaca, strangely enough, has a natural resistance to many fungus, including chytrid. They create an antibody that helps them be resistant to fungal infection. And if we can understand and unlock that, then we can create transgene solutions that can be conferred into the amphibian population. And that is underway right now as well. That was one of the flagship projects that we launched the Colossal Foundation with. And we've now spent $3 million towards this solution, and we've made amazing progress. And I've got a feeling that next year you're going to hear something really cool. So this brings us back to sort of this de-extinction process. And if you guys are mostly not geneticists in the room, so you should be asking yourselves, well, why does it stop here? Because there's so much work over here. And that's what I try to tell the people at my company, too. It's like, you guys are really smart. You did something very cool, but holy crap, have you looked at over here? Right? Rewilding is so hard. You guys have done amazing work. What's been happening here in the UK and continental Europe is an inspiration. The rewilding movement has been amazing. None of this is possible without the work that you have all done. So now what we're doing today is how do we lay the groundwork for eventual reintroduction of a lost species? So the first thing is working with our amazing friends at the organization Rewild. We're funding Rewild to help kickstart the first ever de-extinction framework to really focus on de-extinction technology as we know it today and how it should be responsibly, ethically, legally applied as a conservation tool. But seeing as things move much faster than in the private sector than they might in the conservation sector, we've already launched and told the world we were going to make these things, so we better figure out how to do that while people also give us nice guardrails. So we've also launched the Tasmanian Thylacine Advisory Committee. That is a committee that was built by the mayor of Derwent Valley, Michelle Tricoulis. She is a political leader in the Hobart region that's allowing us to help build a stakeholders group, a group in which we can engage with them on a regular basis. We can show them what we're doing, sort of pull the curtain back, understand the state of today, the state of the art of possible today, and then what groups should be represented in there. So the locals have amazing representation from industry, including logging, who should hate this idea, right? Including tourism, who would love this idea, including locals that might not want a predator in their backyard, including locals who swear the Tasmanian tiger watched them pump gas the other day. Right, it's a whole blended group of people, but the idea is that we can go to the people most impacted, most responsible for the to steward their land, and ask them how should we go about these things. So that's what's underway today. One of the really cool things about our company, I didn't make these slides, right? We have got a cool marketing team that makes fun slides, is that we do have that marketing ability. And what came out of one of our meetings with this thylacine advisory group was this idea that about 1/3 of all Tasmanians are functionally illiterate. So if we want to put things on a website, that's great, but 1/3 of our audience might not receive that information. So we devised this YouTube series, animated YouTube series, in which we can talk about de-extincting Tassie. Right? How do we restore this iconic animal to your landscape? Why is it important? How do you do it? How do you engage with it? And so we did. We just created this really cool YouTube series. You can go on our website, our YouTube channel, you see it. It's a 5-part series right now. It's super cute. It reminds me of Mr. DNA from Jurassic Park. But it's the idea that we can find various ways to help engage the public, to educate them, to get them excited about something strange and hard to talk about. Additionally, we're working with independent researchers to create what we call conservation value and risk assessment forms. It's a really long, boring term to say somebody's going to look into this. They're going to do all the research, the literature review, the study, the sociology required to understand if you bring this species back, what is its value to nature? What is its value to humanity? And if you bring it back, what are the risks that you will expose the world to? That way, we can start to create plans to sort of mitigate those risks and enhance those values. So we're doing that right now. Dr. Josh Donlan from Advanced Conservation Strategies is helping us do just that very thing. Rewild is a huge partner in all of our rewilding and conservation efforts as well. We're also trying to understand what are the predator-prey relationships in the lost Tasmanian ecosystem. We have got a study site in central Tasmania right now that's about 5,000 acres. This is this handsome mustached man here. That's Dr. Andrew Pask from the University of Melbourne. He has ecology students that are out there getting baseline ecological data. What is the current biodiversity of this region? What is the presence and abundance of invasive species? What wildlife diseases are present? So we can really get amazing data today, begin to mitigate for some of the negative things that they might find, and then measure that against the reintroduction of a Tasmanian tiger one day. And then finally, we're also modeling off of amazing partners like AussieArk, how AussieArk is rewilding sections of mainland Australia using Tassie devils, to reintroduce them to the Barrington tops. So we're supporting their efforts. We're working with them so that we can really have this amazing opportunity to help display the power of rewilding to the Australian people and Tasmanian audience, but also really talk about what does it look like when we bring a species back that's been gone for thousands of years. The devil left mainland Australia thousands of years ago. So it's an amazing opportunity for us to sort of highlight all of those for our audiences. And so finally, I'll quit jammering at you so that we can really talk about more interesting things. But I wanted to, when I was thinking about this talk, I was sort of thinking about how none of this weird science is possible without the amazing work of the rewilding community, without the rewilding movement. This idea of trying to restore nature to where it's been lost is incredible and is truly the inspiration for Colossal. But one of the things I've always heard as a critique against Colossal is it's a distraction. It's taking money away from other more meaningful causes. And I totally get that. But first, I can assure you, the money that we brought in is coming from places that unfortunately won't fund conservation. However, I do believe that de-extinction is an enhancing factor to conservation. We have built ourselves, we are not a silver bullet solution. We have built our strategies on the back of conventional conservation. Rewilding is built on the back of conventional conservation. And we are built on top of rewilding. This idea that if we have species that we can use to create these top-down effects within an ecosystem by restoring them to nature, that is a rewilding movement. But what's really interesting is we're not just siphoning off of the success of conventional conservation or of rewilding. We believe that we truly have this trickle-down effect as well. As we achieve success, we're creating technologies that then can be applied to each of the layers below us. And so we only live and thrive because of the success of you in the room. We only live and thrive because of the success of 150 years of this amazing conservation movement. So I just wanted to leave you with that one thought, because I do believe that there are times where sometimes when you have the power of de-extinction, you might get a little full of yourself. I assure you, we don't. We are really grateful to you, to the rewilding movement. We're grateful to Citizen Zoo for letting us highlight some of our work. And I'm grateful for any questions you might have, because I assume nobody has questions. All right, thank you very much. Thank you.
I think, yeah, hang on to that, I think, Matt. Good. So, fantastic. Thank you so much, Matt. We're going to have Matt back in the panel in a moment. So any questions you have, and I'm sure there'll be many, we can pick up as we get into a wider conversation.